All right, first of all, here are my goals. I already stated them to the class. I'm not going to reiterate them, but how could we write the equation for a circle? So if you have a circle, obviously there's a lot of different ways you could make a circle. You can make its diameter bigger or smaller, its radius, therefore bigger or smaller. You can move it around left, right, and everything. Where it all comes from is using the Pythagorean Theorem. Anybody name the situation in the upper right-hand corner? It was in the Wild West, yes. Did you ever hear this saying, circle up the wagons? That's what they would do. No, it wasn't to protect from buffalo. It was to protect from the Indians, who were understandably a little bit ticked that these people are all moving into their area. And they would basically be safer when they felt safer anyway, and they had that big wall around the outside of them. So, okay. So anyway, we are going to derive the equation of a circle from this diagram. So take a look at this. Do you get that this distance right along here is x? That's an x distance, right? It's along the x-axis. That make sense? And then this y distance right here is the up and down distance. And if I just say that this is going to have a radius of 1, do you get that the radius of the circle is this part right here? All right, so now, if you're going to get the equation for it, tell me something that would have to be true about x and y. The triangle, right? This formula should just be screaming out to you right now. Yes? Yes.
X squared plus y squared equals radius.
Yes, a squared plus b squared equals c squared is the classic form of it. And in this case, it's what? X squared plus y squared equals radius squared, which is 1 squared. All right. And that right there is the equation, the parent equation for a circle. If you put that into a computer and asked it to graph it, it would graph it. Now, if you were going to do it on a calculator, though, your calculator wants it in y equals form, right? So then you just have to solve this thing for y. And I've been having you practice that on that top 20 thing, solving an equation that has 2 variables in it for just one of the variables. So solve for y. Everybody take that equation and solve for y. The first thing is you're going to take away what? X squared. Good. And you can stop saying it's 1 squared, because 1 squared is really 1, right? Okay. So then I got y squared equals 1 minus x squared. And now I'm really close to having the y alone. What's left? Square root. And I hope you remember this part too. Remember how I've had you do the square root of y or x a few times, and I keep on telling you the square root of y squared is not y. What is it? Close. It's the absolute value of y, and then that brings in the whole plus or minus thing. So that brings up 2 equations. Y equals the square root of 1 minus x squared, and y equals the negative of that, square root of 1 minus x squared. All right, if you haven't already written something down, you're way behind. You should be writing down not everything, but at least you should get these 2 down, because they are the equations that make a circle. Guess what that negative in front of the function is going to do. It's going to flip it. So when you graph it, you'll see this. Actually, I'd rather have you actually see it. So grab your graphing calculator, and we're going to type in this one, the positive one, first. I'll pause for a minute while we get the calcs going. All right, in case you forgot where the square root is, it's right here. It's right above the x squared. See that blue square root symbol there? Okay, so square root, I go second square root of, and then it puts me underneath the root, and then I say 1 minus x is this button. I'll leave it red for a second so you can see it. Right there, that's x squared, and then I'll just use the squared button. I could have said to the power of 2, but all right, and I hit enter, and then I hit graph, and look at that. Now, should I go back to the y equals screen again so you can see it? It was 1 minus x squared. Okay. All right, you might have issues. First of all, look at your plots. Everybody look at the across the top and see if any of your plot, if yours is having issues, that is. See if any of your plots are on. That sometimes screws it up. Okay, second thing that screws it up is the window. I would use a different zoom this time. There's a special kind of zoom called zoom square, Z square. It's number 5. I would do Z square when you graph it. Is anybody still not working? Okay, check your minus sign and make sure you didn't use a negative sign. Make sure you used a minus sign. I'm going to pause for a moment and clear up some kids' technical issues on their calculators. Okay, got those issues fixed. So, now, take a look. Still, seriously? All right, one more issue. Okay, so here's our half circle. Sorry, I'm not going to stop anymore. I'm done. Okay. Gentlemen? Thank you. All right. Thank you. All right. So there's a top half of the circle here. I bet you can probably figure out what I was going to ask you to do next. Half you already did it without me saying anything. The other equation, which is the exact same thing except negative, you put that on y2. So everybody put a negative in front of it, not a minus sign, a negative in front of it, and then a square root. Be careful, you use the negative button. It's underneath the 3. And then do the same exact thing. Square root of 1 minus x squared. Enter. Okay. And now when I graph this puppy, I have the whole circle. Notice that by doing it that way, both halves pass the vertical line test. Did you hear that? Both halves pass the vertical line test. Therefore, when you do it this way, both parts of the circle are a function. That is important. All right. So, if you move on to the rest of this, it's going to use this other form of the equation because it's so much nicer to work with. But it won't be a true function. Why isn't this a function? Because when you graph it, it comes up with all at once a circle. And does that pass the vertical line test? No. Therefore, a circle, really, a total circle, does not pass the vertical line test. But if you cut it in halves and you say, all right, I got this part of the circle here, that passes the vertical line test. And then the other part of the circle, this, let's say, black part here, that passes the vertical line test. And therefore, if you separate it into 2 parts, you can make it 2 functions together, making a circle. All right, anyway, let's move on. And if we take this equation, this is like, you remember y equals mx plus b? Way back in the day, you learned that. That was the y-intercept. That was the slope. You remember that? You remember the other one that I taught you? Y minus y sub 1 equals m times x minus x sub 1. You remember that? That's on the top 20 thing. Okay. Well, here's another one. This is the form for a circle. And you might say, well, yeah, I'm never going to use that again. Well, if you ever take the ACT test, you will. The ACT test has circles on it. I've done a lot of them for practice, and I've seen them come up a lot. They liked using the circle formula. So, in this is a no-brainer question. What's R? The radius, okay? And then H and K, though. What do you think they are? They're numbers, yes. They're a point. The point that they would be, like let's say it was x minus 3, yes, it's the center. Y minus 7 equals, let's say, 4 squared. If I have that equation, then this point right here of a 3 and a 7 is the circle, the center of the circle, sorry. The center here is at 3, 7, which means that it really moved, just like we're used to, 3 to the right. Is this making sense to you? 3 to the right, and then this one, you can usually trust the y's, but that's because they were on the outside. Now, the y's are on the inside of a parenthesis. and therefore you can't trust them. And therefore what seems like would be moving down 7 right here is actually kind of like the x. You got to do counterintuitive on it. It doesn't move down 7, it moves up 7. So this is a circle that has a radius of 4, and it has been moved to the right 3 and not down 7, but up 7. Right 3 and up 7. So if I made a little sketch of it, the center of the circle is right 3 and up 7 is like right there, and has a radius of 4. Like that-ish. All right. So what's the apparent equation for this circle? Well, first of all, has it been moved left or right? Or up or down? No. All it is a bigger radius than the parent one. So this one just starts with x squared plus y squared. And then what's its radius in this case? Tell me you aren't looking. Pay attention. Thank you. What's the radius of this guy? 3. So I'm going to go 3 squared. There's the equation. Done. Get that? It's because it wasn't moved left or right. All right. Here's another one. It has been moved to the right 3 and up 3. And it's got a new radius of 7. The center is at what? 3, 3. The radius is 7. So what's the equation? Everybody, give it a shot. I'm going to pause for a second while you try to write the equation for me. In the good old days when you could all had iPads, I'd have you billboard it to me. But for right now, just write it down, and I'll have you compare it to a friend in a moment. All right, I'd like you to show the person sitting. Well, actually do it this way. These 2 rows, show the person across from you and see if you got the same thing as them. These 2 rows, show the person across from you. If there's no person across from you, kind of go kitty corner. Same thing here. Show the person across from you. I want to see if you're the same. All right, hopefully you said x minus 3 squared plus y minus 3 squared, and then it equals 7 squared. And you could also said 49, and that would have been fine. Raise your hand if you had it right. Okay, some of you in the back, excuse me, you're going to have a new seat in a moment if you keep doing this. I'm talking, you pay attention. Quit screwing around. Yes?
Obviously, in this position, it doesn't matter if the x is y.
Okay, does it matter if the x and the y are...
It does, because x goes first, right? And y.
Okay, I'm not understanding your question totally, but I can tell you this. This means move to the right 3, and this means move up 3. Is that what you're talking about?
I said y minus 3 squared plus x minus 3.
Oh, I get it. If you put these 2 completely in opposite places, that's totally okay. Because 2 plus 3 is the same as 3 plus 2. Because we're adding them, it will not matter. If these had been dividing, that would have mattered. But okay, let's move on and try one more. This one's a little trickier because it's not to the right and up. So you got to be careful about where the center is. And then after you've written me the equation, then I'm going to talk about domain and range, which is really easy. If you think you get the domain and range just by looking at it, go ahead and write them. Try to answer those 2 questions, the equation for that circle and the domain and the range. Pausing while you work on that. Okay, here's what you should have said. For the equation, you have an x, and then you have a y, and then you have the radius, which in this case is a radius of 3, so you could say 9 here. We could say 3 squared either way. And then it's been moved to the left 2 and up 1. How do I go left 2? That's x is left. How do I go left 2? Plus 2. And then the y has been moved up 1. And I don't trust this as plus 1. I go minus 1. Because the stuff in the parentheses is counterintuitive now. So the y you can't trust anymore. It does the opposite of what you'd expect. Seems like it should go plus 1, but it doesn't. It's a minus 1. All right. Raise your hand if you had that one right. Okay, good. Then the last part, domain and range. The domain of this puppy is this way to this way. And how far does the function go to the left? -5, comma, how far does it go to the right? 1, and that's it. And then the hardest part, parentheses or brackets. You can touch the -5, and you can touch the 1. So therefore, it's brackets. Now, I know you might have looked at this and said, well, yours technically isn't touching the 1. Well, if you were being that picky about it, then that's awesome. but I didn't mean for it to be like that. All right, and then this other one, the range. The range is from how low to how high? -2 to 4. And it touches both. Do you get the domain and range? I think that that's simple. It feels simple to me. So I think you'll get that without much more help from me. All right, so bottom line is, here is the general form of an equation, and they should be able to not even give you a picture. They should be able to just say the center's 2, 7, and the radius is 6. Write me the equation for that really quick. Should be easy if you know what you're doing. Write it. Don't say it. Write it. Just write it. I'm glad you got on a roll there. I'll have you say it for me in just a second, but just hold on. All right, go ahead. You really wanted to say it, so say it. Couldn't stop you before. X minus what? X minus 2?
Yes.
Okay, keep going.
Plus y minus 7 equals 6.
You got it. Raise your hand if you had that right. Okay, good. The only tricky thing we did here is we said diameter of 8. Well, that's kind of just a mean way to do it, because then that just means the radius is what? 4, okay. Okay, so I don't think we need to do any more of these. I think you get it. So I'm going to hand out the worksheet now. And that's all I have for the recording for today.